Welcome to the Tech on Demand podcast and video, and this is going to be an interesting one. As we've discussed in the past in more than a few of our podcasts and videos, the key to successfully producing high-quality crops often starts at the very beginning, and how you and your team approach the earliest stages of germination and propagation sets the stage for uniformity down the line. I'm really happy to welcome back frequent guest, Dr. Will Healy. Will is recently retired as Senior Manager of the Ball Technical Services team, but Will continues to think about ways to share his knowledge and decades of experience with growers of all shapes and sizes. He's worked with a lot of them on a lot of different crops and has a lot of great information to share, and this time he's here to focus on seed-raised petunias. Will, how are things going as you settle into your retirement, and why did you contact me to put together content on petunias?
Well, Bill, thanks for inviting me to talk about a topic that you could say I know of a little bit about. I've only spent probably 30 years with Ball and another 10 years before that dealing with growers who were trying to get uniform germination of petunias. And what triggered this whole achieving uniform petunia germination and flowering thought was during the Facebook last year, I saw a number of different growers commenting, lamenting, challenged with getting uniform flowering of their plants at the end of the season. How do they get growth regulators applied more uniformly? And of course, it all basically traces back to uniformity of flowering. If you take a look at our opening slide, you can see some of these little runts and some of these big mature ones. You can see all different leaf counts, and of course it all goes back to if you can get uniform germination, uniform establishment at the start, they basically poop along right on pretty much on schedule. And so it's taken me about a year to pull this all together because, in retirement, there's so many things going on that you have to deal with. So what I wanted to do is talk about this topic because petunias can be a challenge for growers, especially if they miss out on a couple of key things. And there's just only a couple. So let's really focus on what do we need to do to be more uniform germination. Does that sound like a good plan, Bill?
It sounds like a great plan. It makes a lot of sense. Petunias are obviously a very key spring plant, and I'm sure that our viewers and listeners are going to pick up a lot of tips and tricks as you take us through the process. And you mentioned the Facebook group, and that's the Greenhouse Tech Team Facebook group that we moderate through the Ball Tech on Demand team. And you're right, there were a lot of germination questions. Sometimes I think, wow, I don't know how many people are germinating their own seeds these days because of the rise of plug production, but there are a lot of all sizes and all across North America and around the world. So this information is definitely going to be relevant to quite a wide audience. So why don't you go ahead and get started? And if I have questions, I'm going to jump in and ask them. But you know a lot about this, so why don't you take it away?
Okay, because, first of all, when you buy high-quality seed fresh every year, and that's really critical, the seed has been tested before it's shipped. It tends to have a high germination. If you buy it from Ball Seed, you can get a BVI, which will help you identify the uniformity of germination. And so when you get a high BVI and a high germination, and then experience uneven germination, let's talk about that problem, because high quality seed that has high BVI is going to perform uniformly if you follow the key factors. Let's just talk about uniform seedling stands, because first of all, let's define a few topics, Bill, because otherwise people get really confused. Because some people say it's germinated when the leaves have unfolded. Well, no, that's not true, because the germination, let's talk about it as a process. The germination process, it begins when the water is absorbed by that seed, and that's really important that it uniformly absorbs water, and it basically, germination process ends when that radicle, that little root, leaves the seed. That is the technical period of germination. So Once the root has elongated, it has technically germinated. So we're really talking about really early stages when actually you probably don't even see much, because when you get to the hook where basically the seed's starting to step out of the soil and the cotyledons unfold, you're way past that point. One of the things that you really want to be thinking about always is how uniform, how synchronized is that germination, that absorption of water, that radical elongating, and then consequently the hypocotyls, the hypocotyl elongating, the cotyledons unfolding. What we always talk about is the 48-hour window. What that means is that once it starts, anything that unfolds within that first 48 hours is uniform. It's because with petunias there's a little bit of variability in growth rate, but that first 48 hours from the first one to what is there at 48 hours is critical, because if they start showing up at 72, 96, 5 days, 6 days after the first ones, those are going to most likely be nothing but trouble. They're going to be weaker. You're never going to be able to water them correctly. You're not going to be able to growth regulate them correctly. They're going to actually, with data that we've done over the years, they're actually going to flower up to a week later than the plants that all germinate within that 48 hours. So it's really important that we focus on getting that uniform stand within that 48-hour window. It's not 48 hours after sowing. Let's just be real clear on that, Bill. It's that 48 hours once it starts, 48 hours, 2 days later, what's there. Because if we take a look at the picture that just showed up, what we see is the group on the left basically are in that 96, 4 days, 5 days, 6 days later. Those ones that are circled, they're not bad seedlings. There are no bad seedlings. It's just that they're just late to the party. And of course, if you're late to the party, Bill, don't you usually miss all the good stuff?
Yeah, you miss the food, you miss all the fun, and those certainly look late.
And you're kind of out of place. And so we really want to be very uniform, and that translates into uniform seedling leaf count. Okay. A lot of people say, well, it's all about temperature. No, temperature is a modulator. It just basically modulates how fast. If you germinate very cool, it's all very slow. If you germinate really warmer, it's all very fast. So, when they talk about optimum temperatures, that's important. Let's not forget that, but let's not get transfixed on that, because it's really, as we will find out, it's about water triggering it as a key factor. So let's go and review, and if you've listened to any of the Achieving Uniform Germination presentations that I've done, you'll recognize this slide, but let's really focus on this, because every single class, every single petunias and impatiens and begonias, they all have something a little bit different, and that little bit different is the thing that growers consistently do wrong. There's first three steps. The first step is the pellet melts or dissolves. We do not wash the pellet off, because if you wash it off, what you have a high probability of doing is basically burying the seed, and that's going to be a problem in a second when we talk about it. But you really want to just melt it, and if you think about it as melting, you'll be able to see it in a little while when we talk about a little bit more detail. But melting, you're going to basically it's there surrounding the seed, because when you melt it, what it does is that pellet basically is either a clay, which of course holds water, or it could be a vermiculite, depending upon who's doing the pelleting, and that can hold water. And that's really important, because that water being held by that pellet actually increases the uniformity of water absorption by that seed coat. So if you wash all the pellet powder away, you're basically exposing the seed to, what'd you think, Bill? Dry soil?
Yeah.
Dry air?
Dry right out.
Yeah, and it dries out, and it violates step B, which is the seed coat is not uniformly absorbing water. When you have ununiform germination, it is because it has not uniformly absorbed water from seed to seed to seed to seed. So that's why we like to just melt that pellet, so that pellet has a chance to just be there to help balance the moisture in and around the seed. Once that seed coat absorbs water, then that water moves into the inner membrane, and then starts triggering the gibberellins. And this is all about water. That first
And
48 hours, Bill, it's about water. And if
And
you
that
don't
seems
get
to
that,
usually be the case. It's that moisture management. It's
yep,
keeping the moisture uniform all the way, through some of the even first stages after germination. So really, the difference that you're talking about here with this slide is that step of melting off the pellet.
yeah, yes,
Okay.
and not washing it off. Because if by day 2 or day 3 you can't see a little pellet powder down there in the pot, you're in trouble. Conversely, and we're going to talk about this, I'll just mention it now, is you also want to make sure that that pellet opens up, because sometimes if you don't put enough water, the pellet does not harden. In fact, what happens is that there's an outside glue. Think of it as an egg. So when they make the pellet, they put a coating on the outside. So you get it a little bit wet. What it does is it basically takes that outside glue and pushes it into the seed, and actually you create ball bearings. So when you start getting, 7, 10 days after you sowed the seed, and you can actually see the pellet still fully round, fully intact, that's will never germinate. You basically created a ball bearing that is not going to crack open, and so therefore you didn't put enough water. That water in the beginning is all critical in this uniform petunias. And we're going to talk more detail of what do we mean by too much, too little, just right. Because saying put enough water is a useless piece of information, because we can quantify this into exact numbers to be successful. So anyway, so let's just talk a little bit about what happens now that we got the water in it, and then it kind of got the ball rolling. One thing that's different about petunias is there is a light requirement on some varieties. So this is why we want to be very sensitive to not bury the seed, because if you bury the seed, it's in the dark. And so therefore it's going to germinate at a later time. And we're going to talk about how do you end up inadvertently burying the seed, and we're going to talk about that in a little bit later when we talk about sowing. But let's just remember, not all petunias require light, but there's enough of them out there that will periodically need light, that we just want to make sure that we've got light always on the petunias after they have absorbed moisture. Okay, once you basically have got the water in there, and if they're exposed to light, it basically, then the starch starts breaking down, and the cells start multiplying, and then they start triggering all kinds of growth, because you're basically transcribing DNA into RNA, and growth starts to occur, and that all requires oxygen, and that's why we need to go through wet and dry cycles. Not as critical as petunias as it was with pansies that we've talked about, or impatiens that we talk about, but it's really important that we don't end up creating a gel coat which prevents oxygen uptake by that seed. So make sure that you go through wet dry, and we're going to quantify what is wet and what is dry. At that point, the growth is basically causing the seed coat to crack, and then the radicle starts to emerge, and then we're off to running, and germination process is now done, as we've mentioned before. So let's now get down to the nuts and bolts of where growers fail. Soil moisture at the time of flat filling is really important. We need to be at a level 3, level 3.5. So if we take a look at moisture weights, and I think, Bill, there is a webinar and podcast on moisture management, isn't there?
Yep, and I will put the links in the video description and show notes. We definitely have a good video on training your team to water that talks about the importance of weighing trays.
Yeah, and it also tells you how to calculate what is level 3, level 4, level 2, level 5 for your individual tray soil configuration. But let's just, for the sake of this conversation, let's just say that a level 3 is about 1100, level 3.5 is probably going to be 12 and a half, 1200 grams. But that's kind of what the weight of the tray, and you should be weighing them to make sure that they are at the right moisture level, because that's the starting point. Because if you start at 800 and you run it through a water tunnel and you add 3 more, well, then you're only at 1100 grams, because you started at 800 and then you add 300 more in the water tunnel. 300 plus 800 is 1100. If you start at 1400 and you add 300, well, now you're at 1700 and you're saturated. Now that's a whole nother set of problems. So let's make sure that you got the right moisture before you ever drop seed on it. And this is the first place growers consistently make mistakes. Because what happens when you don't have the right amount of moisture? This is an example with snapdragons, where basically you end up with this hypocotyl, that's that stem below the cotyledons. Sometimes they're tall, sometimes they're short, and that's because you've got ununiform moisture going into the tray. Now, how do you know that you've got that? Well, a lot of times if you take trays and set them out on the bench and just see what they look like after 24 hours, and you start seeing this checkerboard of wet and dry, that basically is where you're going to end up with very ununiform germination and ununiform stands, because the soil moisture is not uniform. Because remember, once the soil is in that tray, everything you do from that point on is done very uniformly. You water it with booms, you water it with the water tunnel. Everything is applied uniformly. So if you have ununiformity within the tray and you apply a uniform amount of moisture, you're not going to fix it. No one has ever fixed this little picture down in the bottom left-hand corner. We got the checkboard. They never fix it until probably about 2 to 3 weeks after it's sown. And at that point, as we said, 48 hours from first to last, dependent upon what happens between the time you sow it till the first seedlings come up. So by the time you can fix it at 3 weeks after sowing, the game's over. The ununiformity is now the name of the game. And so to get uniform, you got to start uniform. I can't stress this enough, and it all goes back to the flat filler. Are you applying the moisture uniformly in the flat filler? Are you making sure that there's not dry soil on your flat? When you're in the flat filling process, in the bin that you are using on the flat filler itself, that flat filler should be the cleanest piece of equipment in your operation every single night. There should not be soil that's sitting on the flat filler, because that dried out soil is going to fall into the tray and will create these problems. It seems like, and this is the kind of little things that, it just, it broke my heart when I read on the Facebook site, and people would have these problems, and I could see dry soil, and I'm thinking, how do you explain to them clearly and succinctly, dudes, you got to clean up your act back at the flat filler, at the flat and the soil mixing, and before you ever sow the seed, you're creating the nightmare before you start. So starting right here is really important. Centering and getting it in the light is really important with petunias, especially if you're mechanizing any of the process, you're doing gapping or anything. It's important to get that seed in the middle of the tray. Notice I'm getting an example where you can clearly see that seed is not in the center of the cell. The seed is basically off-centered, and actually then it tends to be the ones in the top of the picture are towards the front of the cell, and then as it moves through, it's in the back, and you say, well, why is that? And another problem that we have now, I don't know, Bill, can you see how there's almost like a little ledge? Mm-hmm. And because if you really look at that carefully, you can see this little ledge show up, and that has to do with how you dibble it. So these are two different problems that we're looking at. One is you're not getting the drum centered over the tray, or the tray centered under the drum, or you're not getting that dibbler set correctly. And this is one of the biggest problems that we have, is that people buy their seeder, they buy their dibbler, they buy the trays, and this is a matched set. Now let's repeat that. It is a matched set of 3 pieces to ensure that you've got seed in the center of the cell. So if you basically say, I've got cheaper trays or a little bit different trays, that starts moving the seed because the drum doesn't match the tray. And then, by the way, if you have an old dibbler that basically scoops the soil, you build this little ridge that basically is there. Now, why is that important? Well, when you start then running that ridge through the flat filler, it actually ends up burying the seed. And if you notice, the seed in some of these, in this one row, right below the drum, you can see where some of the seed has actually been buried. Can you see that, Bill, over on the left-hand side?
Yep.
The last two ones on the left, they're basically buried. And that's just because they ran through and the soil was pushed over the seed. And remember, one of the things that we said about that's critical for petunia germination is, Bill, what?
Not burying the seed.
Yep, because they got to have light.
Right.
So this is really important that you basically do that. So when you start looking at your seeding operation, as you get started in these season, make sure those guides are in the right place, make sure that the drum is right, make sure that everything is lined up and is dropping seed dead center in the middle of the cell so that you actually can maximize your uniformity. It's the little things that basically start taking germination percentages off. So when people buy 95% germ seed with a BVI of 750 and they basically say, you know, I ended up with about 82% usable, I can basically take them back to the seeder and show them that A, they're not getting the seed in the middle of the cell. B, their dribbler is basically scooping soil and burying the seed. Then of course then it goes into the whole water and problem. But a lot of times it's right here where the problems start. So let's talk about the water tunnel, because this is where all the magic really begins. Your water tunnel basically has different nozzles, okay, right? And each nozzle has a very specific purpose. You know, it's just not there to add water. The purpose of those nozzles is to, one, the first nozzle is basically puts enough water that it glues the seed in place so it doesn't move as it's going through the next nozzles. The next nozzle, nozzle number 3, nozzle number 2, they're used to basically ensure that you have the target moistures in the tray by the time it hits the end of the line of the water tunnel line. So what do we need to do? This is where we need to qualify the information into quantifiable numbers. Qualifying means too wet, too dry. Quantify means that we put an actual number to that tray. And measuring the trays, you don't have to measure every tray, but you do have to go, and when you first get started, making sure that you've got the speed of the belts right, that you've got enough water pressure going through, that you're hitting the right target. Where we see lack of uniformity of pellet germination is consistently where the growers are not putting enough water on the pellet at the time of sowing. You know, we talked about this hardening of the pellet creating ball bearings. It's because a lot of times when they're sowing raw seed, you know, for example, impatiens is a raw seed. Begonias are not a raw seed. That's a pelleted seed. Pansies is a raw seed. We have to use a little bit different moisture because we have a pellet present in that tray. So if we say that we want to make sure that we've got 1,100 grams for a non-pelleted product, so raw seed, but we may need to add an extra 100 grams, so we need to be at 1,200 or even as high as 1,300 grams at the time we're done sowing, so that we have that correct amount of moisture on that pellet so that it starts cracking open slightly, and we'll see that in a minute, and that it's basically starting to melt as it's coming through the process. Also, the thing that you want to check is, what do our pellets look like at 4 days, 5 days after we have sown them? Because if the pellets are still fully intact at day 2, at day 3, at day 4, you're not putting enough water on at day 0. So what we normally recommend is up it by about 100 grams, and you would be amazed at the difference 100 grams of water will make at the time of sowing. It's you know, people say 100 grams. I mean, really? Yes, it is shocking how much that 100-gram difference will make. So really focus on this to make sure that your pellets are melting on time all the time. The other thing that you may want to consider is in some operations, they sow and then they put it up on racks and then periodically take that rack and then move that rack out to the greenhouse or put it in a germ chamber or just move it somewhere else. Now, how dry do you think a sowing area is, Bill?
It's dry.
Very dry.
Very dry.
I've seen people basically nuke germination. They've taken seed that was 95% germ and take it down to 60% germ only because they sowed it, they put it on a rack, and they went to lunch.
Yeah.
And we've done studies and looked at how fast stuff dries. And, an hour in a dry germ sowing area is enough to basically harden that pellet. So if you are in a situation where you have to hold the trays on racks for a while, or you can't move them for whatever reason, they're going to be in a dry area, what you may want to do is put a little extra water on those trays just to make sure that you're not going to dry out. So that's another way that you can kind of monitor what's going. So this whole tray weight is the next key to making sure that you've got success. So let's just look at what's happening when we to some seed. And this is day 0, where we have level is where the moisture level is high enough. It's not less than the level 2. Then we basically move on to day 2. We move on to day 3, and notice that in this case with pansies, notice the seed is already starting to crack. You don't see this normally because you're either not looking at it or the seed may have started to get soil on it, so it's hard to find. But by day 4 and by day 5 on many seeds, the radical is already starting to come out. And this is why we start talking. This is where we would start looking at shortly after as you go on to day 6. You'd really be concerned that are you going to get seed to germinate? Remember that if it's too dry, you're not going to get the development. If it gets too wet, and this is where growers go out there and mist on a timer, and they just mist because, well, it's time to mist, and they just keep putting more and more water on these seeds. And what they're doing is they're going to slowly start forming this gel coat, which basically stops germination. Because remember what we talked about, the first step was water for germination process, and the second step was oxygen. And if you have the gel coat on it, you do not get the oxygen into the seed. So really, let's make sure that you're using your correct moisture levels, and every organization is going to have a little bit different optimum moisture levels that they want to water up to, and then they want to dry down to. So this is really important, especially as we start looking at pellets. So let's just talk about melting that pellet, okay? So here's a good example of ball bearings. This is some dianthus that a grower was basically complaining. Dianthus is one of the most uniform germinating crops that you could have. It comes up like sod, except in this case. And they said, well, what's the problem? We went out there and we looked at it, and sure enough, look at all those pellets that are, can you see all those pellets, Bill?
Mm-hmm. Yeah, they haven't broken down at all.
Yeah, I mean, don't they look like cracked eggs?
They do.
So when you go to know, are you getting enough water on it, you do the pencil test. So you take a sharp pencil, and I usually use a pencil versus a pen because a pen can be sticky and it pulls the seed away, so use a pencil. Use a pointed pencil, and you just kind of tap that pellet. If you tap the pellet and it gives away, so it just kind of starts breaking or melting away at the end of the sowing line, you know that you're on the right track. 24 hours later, you go and you check it again, and that pellet just basically is kind of mushy. That's the right moisture level. There you've got the right weights. If you go out there after 24 hours and you got little ball bearings out there that you have to really push hard and they crack open, you need to go back and say, let's try another 100 grams of water. coming off the sowing line because we're drying them out a little bit too much, or we're not getting enough water on them. Now, just a common comment is the ball pellets, the yellow pellets, are melting pellets. There is another type of pellet that sometimes you see out of European operations, European suppliers, which are cracking pellets. It's a pellet that's used for field crops. And the pellet actually, called a split pellet, and it'll actually split open. But that too, by day 2, should have split open. So like basically think of it as it cracks open like a pea. So it basically cracks in half. So either way, whether you've got a split pellet or you've got a melting pellet from ball, you really need to make sure that they are melting correctly, because when you have this, clearly this is not going to work. So making sure that you got enough water to soften the pellet. Notice that these are pellets on basically one day after, and you can kind of see there's a range of what they look like, but notice how they've all opened up a little bit. And these are just naturally open. Keep the moisture so that you prevent this from drying out. And that notice how they slowly but surely are starting, and the one down in the bottom right hand corner of this 4 cells, that one did not get enough water. It's not cracked at all. So what should they look like? If you got a really good eyesight, you can actually see this, where you end up with by day 3, you should have this little ball of oatmeal. This is the white pelleting powder, and you can actually see a little bit of a seed sitting there. Usually what we do is we take a picture of it and then just blow it up, and you can actually see it very clearly. That tells you you're on the right track. Notice the soil is moist, the pelleting powder is moist, and now we're in good. So you want that bowl of oatmeal with a raisin on top. So how do we do this from a water management standpoint? It's not just being wet, but it's also being dry, because we want to make sure that we don't form that gel coat. So if we think about what we're doing, is that once we've sown the seed, we have a hydration phase. And notice in this case, we watered it up about 1,200 grams. Then we dry it back down to 1,000 grams. And when it hits 1,000 grams, we apply we apply 200 grams of moisture to get it back up. And that you can do with booms or even with mist nozzles, by knowing that this amount of time or this many passes will place this much water on that tray, so that you can actually manage the moisture very carefully. Then we go into cell division. Notice one of the things we did was we were continuing to add a little bit more moisture as we came to the end of hydration, just to make sure that we're uniformly hydrating them. But then again, we start drying it back. And notice how as we go through cell division, we're even drying it a little bit more than 1,000 grams. We even let it go just a little bit more, because we want to make sure that we're now starting to get really good performance. Then finally, once we've got the cell division, we start getting rooting. Now we need to really start drying them back. Notice by day 10, we're basically taking it down to about 850 grams, because that we want to make sure that we're drying it out to start forcing that root to start taking off and going. And then we start continuing to go through wet and dry cycles. And it's really important to take it through wet and dry cycles, because when you don't, you end up with the infamous root running problem. Root running, where the roots fail to enter into the soil, is really an indication that the plant has got more than enough water in the surface and there is no oxygen. If you look really carefully at that root that's going across that soil, you can actually see some branches where it's sitting out in the air, because one of our common statements when we talk about watering is the statement of fish grow in water, roots grow in air. And that's why we want to dry out the soils, to enhance that root development. And of course, when we see that we have constant high moisture, 4+, where we're continuously misting, especially after that initial hydration, basically we're at 1,400 plus grams, we're going to see this root running across the surface. Now, a lot of times people will say, whoa, it's about soil compaction. Well, when you water a lot, you actually end up compacting the soil. And Bill, didn't we do a different webinar about how you can grow algae and sludge and it compacts it? Isn't there
Yep.
also a podcast on that?
Yeah, it was the slime, mold, and algae podcast and video that everybody liked so much, and he had some pretty ugly pictures in that one of some definitely a lot of slime and mold on the top of these plug trays. But this was your exact point: was that compaction that was caused by over irrigation.
Yep. And so we really want to watch that very carefully, because if you start seeing this where the roots don't go down, you need to start asking yourself, why are we putting this much water? What's happening here? Are we compacting that soil? Is the flat filler compacting it too much? Because that can always happen also. But usually it's because you're putting too much water either to and that you're not getting that root to come out and go down. That's really important. You've got to get that root down, especially in that as you start going into that 48 hours. Just make sure also that if you see it extensively, if you have really weird pH and EC outside the normal ranges, and this is a pretty broad where it's very acidic down to 4, down below 5, down to 4.5 and stuff, that can be a problem. You have very, very high EC, that can be a problem too. But normally, if you've got good soil from a reputable soil supplier, that's really not the problem. It's usually just a water issue. And excess soil compaction sometimes, but usually it's you're too wet. So, in summary, we've talked about a bunch of things, but let's just talk about the summaries. How do we achieve uniform petunia stance? How do we get that uniform? And of course, what we want to do is we really need to focus on that critical moisture level. If we have that critical moisture level, and do you have your targets? Do you have your starting point? What is your target? As it comes out of the water tunnel to that first 48 hours, making sure that you have not dried that pellet out, checking that pellet with the pencil, doing the pencil test on it to make sure that the pellet is starting to melt and you haven't washed that pellet out. Making sure that as you go from day 3 to day 8, that you begin to dry it out a little bit so that you have a dry target and a wet target, so that you're oscillating between wet and dry. You're not just keeping it uniformly wet, because I see a lot of times when you have a lot of root running is because in this day 3 and 8 they've just been pushing water. There's this old wives' tale of, to get more uniform germination you just have to water more. Well, no, that's not the way it works. It's actually making sure that you go through wet and dry cycles on day 3 to 8. And then making sure that, do you have a change point? At what point are you basically moving from the moisture issue of keeping it a little bit wetter to basically going to a drier conditions, so that you're basically changing your dry target and also your wet target? So that usually that change point is when you have about 40 to 60% of the cotyledons have begun to unfold, and because that usually from the time you go to the where the cotyledons first start showing up, we're at the hook until they unfold. That's usually about 24 hours, so it happens very fast. So right in that 40 to 60% of the cotyledons unfolded, that's the point that you want to basically transition from what is your wet target and what is your dry target, to make sure that you've got new targets compared to when you start the germination process. So those, when I see where is the problem, it usually goes back to moisture management right there. So is there anything else, Bill, that we've talked about that you think that we should be trying to remember that's critical?
Well, I think, it occurs to me that if you don't manage the moisture correctly, if you haven't gone in ahead of time, learned the weights of your trays, tested your dibbler, tested the drum that's seeding, and done a lot of this upfront sort of maintenance and work before the seed even arrives at your greenhouse. These are things that can be done in the off season, because if that seed has been tested to germinate at 95%, and consistently year after year you're getting 85% germination out of it, there's something in the process that needs to be corrected.
Yep.
And I think that, if you're listening to this and watching this in real time, I mean, we're getting to the holiday season, and there should be some time at the beginning of the year to get this all squared away before the seed starts arriving in the greenhouse. And then the other point, Will, that I think is probably worth reiterating is that the burying the seed component, because with petunias and a few other crops, I think this is extremely critical and probably somewhat unique, or something that just might be forgotten. But it's also something that I think growers can go over with their teams. This is the kind of thing that can be trained and reminded and noted, don't you think?
Oh yeah, because the and words matter, and so this is where I always say, let's talk about melting that pellet. Let's talk about the having a little oatmeal with a seed on top, with a raisin on top, so that we're not talking about washing the pellet off. When people say wash the pellet off, then a little bit of water turns into a lot of water, because people want to do a really good job. And when you wash, what do? You pour the water, you're firemen out there. And that buries the seed. Then you run into the light problem if it is light sensitive, and you just run into a lot of different problems. So when you're training your growers, make sure that you use the right words so that you don't end up confusing them. So talk about it melting. Don't talk about wetter, drier. Talk about how many more grams should we be doing. Should we put another 100 grams on? Should we put 100 less grams on? Should we, what should we be doing so that we're more directive? And then all of a sudden, petunia germination pretty much becomes a no-brainer. So,
excellent. We like no-brainers, and I also like that you have this as your closing slide, because one of the things that we really try to do through Tech on Demand here at Ball is to give you multiple ways to find the information. Everybody has different learning styles. Perhaps you want to read about it in the weekly newsletter. Perhaps you want to watch a video. You might want to listen to it in a podcast on your way to and from the greenhouse, or when you're out walking the dog. And if you want to engage with a large community of more than 4,000 or 5,000 growers around the world, we do have a Facebook group as well, so you can engage socially. I will put links to all of these different resources in the show notes and the video description. And if you want to see all sorts of people on the Ball Tech team giving talks and presentations that you can share with your greenhouse team for training and refreshing, we've got you covered. And I think with that, I am Bill Calkins with Tech on Demand, reminding you can subscribe to the Ball Seed YouTube channel to see more than 100 Tech on Demand videos, and to the Tech on Demand podcast brought to you by Grower Talks. We're on all of the different podcast apps, so pick your favorite. Find the Greenhouse, the Grower Talks, Ball Tech on Demand podcast, and you'll find more than 100 episodes as well. So, Will, thank you very much for your time, and I think we'll be back with some other crops, don't you think?
oh yeah, absolutely, because there are other problem children we need to talk about.
Excellent. Well, we will be covering those in due time. Take care out there.